a second time around because the audio didn't record the first time, and I don't really want to voice over my recording. So all that I've done here so far is I've gone ahead and inserted that drawing view into our front and our top plane here, just so we can quickly have those dimensions for us. And it's been roughly scaled to around the same size we'll be looking at it with. So there's two methods I think we can / should be able to do this with. One of them is purely creating it in the 3D sketch environment, and then the other method is projecting two 2D curves into each other, except that does have some funkiness. So the other weird thing about this is that this right here, 48, we're only given the 48 radius in the top view, which seems to be implying that those radiuses are actually in that projected view. So their radius is 48 in the top view, in reference to the top view. But that's kind of really super hard to do for a few different reasons. So we are just going to assume that is 48 in the 3 dimensions. So yeah, all right, we're going to go ahead and get into this. We're also going to assume that the driving dimensions in this model are the linear dimensions, and the angles here are actually just for reference, and we don't care about them. Cool. I think that's everything that we need to get out of the way first. So gonna go ahead, we are just gonna go ahead and make a 3D sketch. So the way that I'm gonna go ahead and do this is I'm going to make our geometry starting on the front plane here, and then I'm going to drag it into 3 dimensions. So in a 3D sketch, whenever you start with something, it will automatically create them normal to the plane. It'll do its best job to interpret your movement. So if you're normal to a primary plane, it's going to create all of those sketch entities on that plane that you're normal to. You can see right around my mouse, we have a few indicators there. First one is XY, the second one is X, and the third one's coincident. So coincident we don't really care about. Along X means that it's making this line along the X axis, which I wish I had my triad popping up down here, whatever. So we're gonna go ahead, because that's what we want. We want this along X. Do that. Then we're gonna go ahead and we're judging off of the front view here. Gonna just make approximately down like that, then one more like that. For each of those, you can see now has this little long X, which is great. But we want this to be out of plane. So we're gonna go ahead and we can just drag. There we go. That's what we're gonna want, or to make that more clear, I Control Z. If we're like, oh, I don't know what to do, we can just go to our top view, like, all right, it looks like one line now. We're just gonna pull it out to the side. There we go, approximately correct. And so one of the things that we're gonna use here, and one of the things I recommend if you're designing directly in 3D sketches, is to use a liberal amount of construction geometry. Just helps to lay stuff out, all that. So, if I tried, even if I was in this top view, if I tried to give this 4408 dimension right here like that, that's not what I wanted to dimension it as. Even if I did some other weird stuff, it's not gonna really work how I want it to. Same thing here. Let's say I want to apply this 63.96. If I go here to here, it's not what I want. If I do here to here, it's not what I want. Even if I do here to here, if I move out of the plane, you realize it's like that. It's not what I want. So I'm going to go ahead and explicitly use some construction geometry here to help me out, just to make sure that these dimensions I'm adding are actually along these axes I want them to be. And so again, you'll see it's popping up that Z, snapping it exactly what I want. Then I'll just connect these 2 dots and then force this one. I believe yes, it is along Y. So now we can start adding our dimensions. Go ahead, start with this at 448.08. in our top view right now, so this is going to be 166.81. Ooh, let's make sure. Yeah, so that is correct. And yeah, we can also just go ahead and dimension the length of this is 88. And let's see what else. 296.68 for here. I think the only dimensions we have left now are our front. 63, you know, we want to use this guy right here, 63.96. Cool. And now we can see down here, fully defined, fully defined. We're good. All right, and now the tricky part comes with these little radiuses. Like I said earlier, we're just going to assume that that is their 3D radius and not a projected radius or something like that. We could use one of these other arc types, but this, the tangent arc, you need a end point to start it with. This isn't super useful. We're just going to go ahead and use a 3-point arc. Start from the top view because it is probably the view that is most nearly normal to this line right here. Just, you know, when we're making things in 3D sketches, specifically curvy stuff like tangent arcs, you see that almost got it right. We just want to try to give SolidWorks an easy time, get as close to your desired solution as possible when you first make it, and then it is more likely to automatically see. When I did it like that, is not what we want to do. It's not close to what we were trying to do. So again, I'm going to move into the top view since it's fairly close to the view we would be using. Select these two, make them tangent. Select these two, make those tangent. And we already got tangent, tangent. And go ahead, set this at what? It's 48 flat. And right here, you know, I could set those to just be equal using a constraint, but I want to make it so that in the future, any other designers will be able to clearly see that how this other arc has been defined. So I'm just going to hit the equals, click that dimension, and there we go. Now it's driven to still be equal. It's just clear how it's being defined. All right, and the last thing here, we want to trim away this excess. So I'm going to go ahead, make sure keep trimmed entities as construction geometry is turned on. Trim that, trim that, trim that, trim that. There we go, yay. And we should be all good. Now, we should be able to, you know, we could click on this, adjust all of our dimensions, and be good to go. So some other people were saying in that thread that doing a sketch on the top plane, sketch on the front plane, and then projecting those curves into one is the way to go. You could do that. That's not really what I would want to do because I want my things to just be in one area, at least for this, since it's a fairly simple sketch. But, you know, I'll go ahead and show that workflow. It is a little bit funky with, again, these things right here, so we're going to have to do some extra steps, but whatever. So, I'm going to go ahead on our front plane, do a sketch right here. Very simple, just like so. 448.08. I guess now would be nice, you know, if we had these all parametric or equation driven, so that we just select the variable instead of, you know, having to do all this typing. Whatever. 296.68, right? 290. There we go, fully defined. And we're gonna go ahead into our top view, and just to make sure, you know, that we actually have all of this stuff linked to each other, and to reduce the possibility of any mess ups, we're gonna go ahead and make these yeah, I don't like that. I'm gonna turn off the visibility of this for now. Just gonna do these like this. Now I'm gonna go ahead and turn the visibility of that back on, and just so we are certain that all right, hopefully we are back. All right, hopefully we are back. My headphones turned off for a second, and that's what I'm using for my mic. So, like I was saying, just to reduce the possibility of errors and misalignments between sketches, we're just going to go ahead and add some relations here to force these to always be the same. Make these, and I'm just going to be using verticals for these. That's, you know, just the projection of the sketch. And our last thing right here is to dimension this at 166.81. 66.81. Shabam! Alright. Now, I'm gonna go ahead and use curves, project curve. Make sure we got sketch on sketch. Shabam! Got this. And now comes a little bit of a funky part, you know, because now we have to have 3D. We have to have you know, sketch 6, sketch 5. I'm gonna go ahead and hide this, but you know, we have to have 2 sketches nested inside of a curve feature, and then on top of that, we have to have a 3D sketch, which we will then use convert entities to get this thing, and then once we have that, now, you know, because I mean, you can see if, oh hey. I was gonna get all sassy and say that sketch fillet won't work, but I guess it does. Shabam. Yeah, well, you know, that works too. You can do it like that if you want. Personally, I kind of prefer the other one. And you know, the sketch fillet might also work in the other method as well. I don't know, I didn't try it. We can try it now though. Let's see. Here's a fun little thing to do. Cool little tool here is we're gonna go ahead and delete this. And now we get to learn sketch repair. Yay! So we can use this extend entities option right here, which is a nested up in here, extend entities. There we go, yay. Woohoo. Alright, whatever. Let's see if this works. Merge points. Not what I wanted. Whatever. 88. Shabam. I like saying shabam. Alright, well, you know what? You learn something new every day. Probably the cleaner way to do it. But, you know, both ways are valid. I just like, personally, I like having things in one area. It just feels tedious to have a feature with 2 nested sketches and then a 3D sketch on top of it when you can just have one 3D sketch. Yeah, hopefully I interpreted everything correctly. Hopefully you found this helpful. If so, let me know. If not, let me know. But be kind about it, please. Alright, I think that's it.